Okay, today we're going to launch into Chapter 5, which we're dealing with quadratic functions. We're skipping ahead a little bit to Section 5.3 to solve quadratic equations by factoring. And then we'll go back to 5.1 and 5.2, which is dealing with them in graphing a little bit later. So let's start in with solving quadratic equations by factoring. Now, first of all, a quadratic equation is just a polynomial that has an x squared term. So you have an x squared term, an x term, and then a constant. There's several ways to find solutions to quadratics, including graphing, factoring, completing the square, and the quadratic formula. And today we're going to focus on factoring. Now, just by way of review, we remember that factoring is the process of unfoiling. Remember, FOIL is where you go first, outside, inside, last, and multiplying two binomials together. And we are going to be, as if you imagine that you multiplied x plus a times x plus b, you would get a quadratic, and it would look like x squared plus ax plus bx plus ab. So given that we'd have a polynomial that would look like x squared plus 8x plus 12, we'd need to figure out a and b such that the two terms that would multiply to give you, add to give you 8 and multiply to give you 12. So what factors of our polynomial can multiply to give us 12 and add to give us 8? So first we want to collect all of the factors that multiply to 12. So we could list them. 12 and 1, 12 times 1 is 12, and then 6 times 2, and then 3 times 4. So we figure out the factors. And then we say, well, which of those two will add together to give us 8? And we look and we see that the 6 and the 2 will add to give us 8. So that is going to be our solution, or our factors. Okay, now there are some special cases of binomial formulas that if you recognize them, you can save time and effort later. They tend to come up frequently. So the first one is just where you have a same binomial that is squared. So a plus b squared is going to give you a squared plus 2ab plus b squared. And you just get good at recognizing these after enough practice. A minus b times a minus b is a minus b quantity squared. And that will give you a squared minus 2ab plus b squared. And finally, a plus b times a minus b. We call that the difference in squares because the a squared minus the b squared is a difference, two squares subtracted from each other. When we factor that, we're going to get an a plus b and an a minus b term. So factoring is a process of breaking a larger polynomial into smaller polynomials, usually a monomial, which would be like the term x, and a binomial, which would be like x plus 3. So if we look at these three, we can factor each of them separately. So we get x squared minus 4x minus 12. That can separate if we factor, and we'll talk you through with some examples how to do that. Negative 6 and 2 will multiply to give you negative 12 and add to give you negative 4. And then the next term, if we divide out the 5s, we'll get a simpler polynomial that we could then factor. And when we factor that one, we're going to see that the solutions are going to be negative 4 and negative 3. And then finally, in the last one, we can factor out a 2x, and we can get x squared minus 16. Now, we'll take you through some example problems, show you how we're going to do this. When we are trying to solve by factoring, we set the equation equal to 0. So we want to get all of the terms on the left side, and then there's 0 on the right. And then we can go ahead and find our solutions. If we have a common factor like, for example, 3 or a 3x, we could take that out of every case. So, for example, number 2 down here, you see it has a 3x, 24x, and 45x. So we could pull a 3x out of that one, and that makes it a little bit easier if you can get rid of common factors. Finally, we understand the notion of zero product property, which is something that says that if a times b is equal to 0, then either a is equal to 0 or b is equal to 0. One of them has to be equal to 0. So we can set each of them to equal to 0 separately to find our solutions. So let's work some example problems. First one, example 1, let's go ahead and get all the terms on one side. X squared minus 5x minus 14 equals 0. So now I want to figure out how I can factor this and figure out what terms can multiply to give me negative 14 and add to give me negative 5. Well, now the first clue is the fact that negative 14. So I know because two numbers have to multiply to give a negative, one of them is going to have to be positive and one of them is going to have to be negative. And when they add together, they're going to give me a negative number. So I'm thinking that the second larger term is going to have to be the more negative one. So let's try this. 1 times negative 14 will give me negative 14, but it won't add to negative 5. So that one's not going to work. Let's try 2 and negative 7. Again, one of the terms has to be negative to get a negative 14. So yes, it multiplies to negative 14 and it adds to negative 5. 2 plus negative 7 will give you negative 5. So I can now write my factors, x plus 2 and x minus 7. Now I want to solve each of these to get my roots because I know that either x plus 2 has to equal 0 or x minus 7 has to equal 0. So I'd write x plus 2 equals 0 or x equals negative 2, and that's one of my roots. Likewise, I can say x minus 7 equals 0 or x equals 7, and that's another root. So those are my two roots to this quadratic equation. Alright, let's take on example 2. Now, as I mentioned, you might be able to factor out a 3x from every term. So let's do that first. 3x times, well, what's left? I have an x squared there, and then minus, I took a 3x out, so that's going to leave an 8x. I'm taking a 3x out of this one, and that's going to leave a 15, and that's equal to 0. So now what I'm going to do is factor this quadratic in here. And I will get, I'll bring the 3x down because that's still true. Let's factor this one. Now the question again is, what terms are going to multiply to 15 and add to negative 8? Well, if I'm going to have a negative term for my negative 8, then I know that the two things that multiply need to be negative. They have to both be negative because a negative times a negative is a positive. So let's try a couple factors. We got, let's see, 1 times 15, or negative 1 times negative 15, I should say. That will multiply to 15, but it's not going to add to negative 8, so that's not going to work. Let's try 5, negative 3 times negative 5. That will multiply to positive 15, and it will add to negative 8, so that's it. I just found it. So x minus 3 and x minus 5. Now, to find my roots, I would say that either 3x is equal to 0, or x equals 0, or x minus 3 equals 0, or x equals 3, or x minus 5 equals 0, or x equals 5. Now I keep saying or, but the truth is it could be and. You could have multiple, all of these things could be equal to 0. So these are each solutions, but you could do or and. It doesn't really make a difference. All right, next examples. Okay, example 3. Once again, let's get all the terms on one side. So I got x squared minus 6x minus 40 equals 0. Okay, so I need factor it. X equals 0. And the question is, what's going to multiply to negative 40 and add to negative 6? So let's try, well, first of all, we're going to have one positive term and one negative term. I don't know which is going to be which yet. But let's try 1 and negative 40. Well, that will multiply to negative 40, but it's not going to add to 6. So let's try 2 and negative 20. That multiplies to negative 40, but it adds to negative 18. That's not going to work. Let's try 4 and negative 10. That multiplies to negative 40 and adds to negative 6. So that's it. We got it. So we got x plus 4 minus 10 equals 0. So I can get x plus 4 equals 0, or x equals negative 4. And I have x minus 10 equals 0, or x equals 10. Let's take a look at the next one. We got 8x squared minus 6x equals 0. Well, they have an x in each of those terms, so I can factor that out right away. I actually have a 2, so I could do that too. So I get 2x, and then I'll have left over a 4x minus 3 equals 0. So that means that 2x is equal to 0, or x equals 0, or 4x minus 3 equals 0, 4x equals 3, x equals 3/4. So there's my two roots, there and here. Alright, let's try the next one. Now this one looks like a special case. This is a difference in squares. And so I know whenever I have a difference in squares, I'm going to get x plus something and x minus something equals 0. And basically all I have to do is look at 25 and say, what's the square root? That's a perfect square. So that is going to be x plus 5 times x minus 5 equals 0. So if I solve that, I'm going to get x plus 5 equals 0, or x equals negative 5. And I'll get x minus 5 equals 0, or x equals 5. Sometimes we'll just write that as x equals plus or minus 5. Example 6 over here, we have x squared minus 4x plus 4 equals 0. That also looks like a special case. That looks to me like I have a perfect square, or a square of terms, so I'd say x minus something squared is equal to 0. So the term that is going to be perfect square is 2. And let's just FOIL that out and see if that makes sense. So I'm going to get, if I multiply that out, I'm going to get